Tomorrow on Daily Planet, wow, they're letting anyone sit in first class these days, eh? We'll airlift some caribou to their brand new home. That's tomorrow.
Time now for another edition of Make the Robots Do It. On tonight's episode, farming.
Growing up on a farm, Charles Fox knows full well how handy this little guy can be.
This is my family farm. I used to do the weed spraying. I used to put the backpack on, and it used to hurt after a while, and it's getting pretty dangerous as well, getting nasty chemicals on you. So I thought I'd get a robot to do it.
Easier said than done. After years of development, Charles is perfecting the Ibex, a self-driving, off-road, robotic weed assassin, keeping grasslands clear for livestock.
Robot gives us a way to spray weeds more like how a human would do it, by being selective, by recognizing small clumps of weeds, ultimately individual weeds, and zapping them one at a time.
That would eliminate the need for bulk spraying, which is a lot less precise.
Ideally, we want to reduce the amount of herbicide down to the bare minimum. Ideally, just putting a single drop of herbicide on one weed plant that's just enough to kill it. So we can help to save the environment, we can reduce labour costs, and we can help to make our farms more efficient. Today we have all three team members here. There's myself and Ed Gummo and Pete Williams. We have all been working in different parts of the country on different parts of the robot, and we will be integrating those components together for the first time. We're going to be finding any problems of components interacting with each other, and then we'll be starting to run some trials.
Yes, I found the problem. So what we had here, you can see there's some burn marks on this washer here. What that indicates to me is that it's just arcing. It's just, as we're driving along, it's vibrating. In theory, all I have to do is to just tighten this bolt up, and we should be good to roll again, which is great.
With the guts open, 4 main components are revealed.
The main one, which is our radio interface, handles our short-range and our long-range radio systems. We have a power module that controls all the batteries. This connects things if things get out of hand. We have our drive module, which interfaces to a number of motor controllers, and a custom-built sprayer module that will handle all of our weed killer spraying applications. The autonomy systems bolt on top of this, so this will talk to those over the radio link.
To make sure the problem is fixed, Ed drives Ibex over some rough terrain via remote control.
Okay, perhaps not that, to be fair. Go on. Right, let's push it over. Come on. That's good. Yeah, so what we're going to do now is we're going to drive it straight back to the workshop. We're going to hand it back over to Charles. He's going to enable the autonomous system to see if I haven't broken them.
I've maybe done worse myself, actually.
What they've done is ripped off the Inertial Measurement Unit, or IMU, a mixture of compass, gyroscope, and accelerometer, all kind of important for autonomous driving.
So the IMU is very sensitive. It's detecting the magnetic field of the Earth. It can be interfered with by all the other electrical equipment here, which is why we put it on a pole to lift it out of the way of that equipment. So when we put it back on, it's got to go exactly where it came from. So hopefully, it should all work again now. Hey, my laptop's kind of muddy. That's the first time we've ever rolled it with this stuff on, so the design is supposed to be robust. I guess we're going to find out if that's true now. We have some flashing lights down here, which is a good sign. We don't have a flashing light in here, which is a bad sign. Okay, now we have a flashing light in here. That's a good sign. There's something is going wrong here, so we may just have to turn it off and turn it on again. It's a high-tech solution. Now we're running autonomously. We've got all the sensors synchronized together. We've got our transmissions coming out of this antenna here. We have two-way communication, and we've planned a route around the field, and we're just going to swathe up and down and try to cover every square metre of the field so that we can look for weeds. We have visual sensors from the cameras. We have 2 forms of GPS. We've got inertial measurement unit. We have a laser scanner. The brain of the robot is in the laptop. This is where all the sensors come together. Our classification basically consists of asking, is it green, is it grass? If it's not grass, then it's probably a weed, and we're going to spray it.
They're still working on the spray system, but Charles easily imagines other onboard weapons.
We could zap weeds with lasers, we could cut them with rotating knives, any kind of weed destruction implement you want to put on the front of this thing. Today's been interesting. We had an exciting mechanical trial. It's the first time we've ever tested a complete rollover of the robot with all its sensors on it. Amazingly, this robot is so well engineered mechanically, it survived the rollover.
Clearly, the Ibex is ready for hard labor down on the farm.
In the UK, nobody wants to be a farmer. The average UK farmer is 65 years old. Their kids don't want to be farmers. I didn't want to be a farmer. I became a computer guy. Someone's got to do it. If it's not going to be people, let's use machines. Eventually, we'd like to replace all the large farm tractors with these smaller precision robots. They could do everything. They could plant the seeds, they could harvest the crop, they can monitor the crop, ultimately have a fully automated robot farm.
Since we never turn our backs on the robots, let's see what else they're doing. This 3D printer can spit out a fully assembled hydraulic robot in a single shot. Most of it anyway. Just needs a motor and a battery to get moving. It's the work of researchers at MIT. They've come up with a method to print solid and liquid materials all at the same time. So to make the hard parts, the printer blasts the liquid plastic with a beam of UV light, and that makes things like the base nice and sturdy. This six-legged robot is just one example of what the system can do. This one has 12 hydraulic pumps inside and a rotating crankshaft to do the pumping. This fast method could make a big difference in the manufacturing world. The system allows researchers to quickly print a soft robotic grip, for example, ready to be plugged into already existing robots.
Ooh, machine inception. Okay, want more awesome machines? The robot gurus at Festo Bionics have just unveiled their latest. Behold, an autonomous flying bubble that grabs water bottles and can drop them off as well. And not just water bottles, it's all kinds of things. 2 cameras help the helium bubble monitor its surroundings as it grips objects. Once it's done grabbing, it uses those 8 lightweight rotors and a built-in navigation system to head to its next destination. And here's another robot that's good with its hands. This one was inspired by spiders and caterpillars. It uses a special resin to build webs and cocoons. The resin can be trimmed with the help of an automated cutting tool, but let it sit for a little while and the strings harden into a sturdy rod, so you can keep it simple or go web crazy and outfit your whole living room with 3D printed furniture.
Up next, step right up and place your bets. Who comes out on top in this battle of the MMA Masters? Sure, clearly the safe money is on the one in the armored suit, but hey, you never know, so come back in a bit.